On the behalf of Government Engineering College Banswara, I, Dr. Sunil Gadhwal, welcomes you once again in online video lecture classes. Today we are going to discuss about the recovery of byproducts by Otto-Hoffmann method. As in the previous class we had discussed about Otto-Hoffmann method, its structure, its working, its advantage and disadvantage. So today we are going to discuss about recovery of the byproduct. As we know that this is the most modern and nowadays industries are adopting this method to convert coal into corresponding coke, and most of the industries are using this method. So how we can recover the byproduct with this method, let's discuss. So the gases which is evolved from the Otto-Hoffmann oven after carbonization is known as coke oven gas. So here you can see this is the columns where we are feeding by opening the top of this column, cast iron gate, putting powdered coal here, then sealing again this oven. Similarly we have to fill all these columns. The number of column depends upon per day requirement of the coke. It may be from 10 to 200 or more than 200, which is as per the requirement. So once we fill all these columns and close this chamber, then we have to pass here producer gases. Along with the producer gases, with this inlet we have to pass air or oxygen supply, and start just a spark, and then this producer gases will burn here and generate the heat. That heat will redirect towards this gap, and the inner line of this chamber is made of silica refractory tiles, so that tile will redirect the heat again towards this chamber side, and these chambers slowly will rise up their temperature, and it is up to 1200 degrees centigrade. So this is the coke oven gases which are coming out through this pipe, and this coke oven gas consists of tar, ammonia, H2S, HCN, naphthalene, benzene, moisture, and lower hydrocarbon, carbon संख्या 1 to 4, plus diesel, petrol, kerosene, and heavy oils. All these byproducts are recovered by special treatment, as we had discussed in previous class also, and here also we will discuss. So the first byproduct is recovery of tar. The hot coke oven gas firstly passes through a thaw in which liquid ammonia is sprayed from the top, and the tar get collected in the tank below. The tar can be used for road making and for preserving timbers. Okay. Second byproduct is recovery of ammonia. The remained hot gas then passed in another tower where ice cold water is sprayed. Ammonia goes into solution form as ammonium hydroxide. The third product is formation of ammonium sulfates. Remaining ammonia can also be recovered by spraying cold H2SO4 in third tower, and we will get ammonium sulfate, and this ammonium sulfate can be used as a fertilizer in agriculture field. Then recovery of naphthalene. The gases are then passed through a tower where ice cold water is sprayed, and the naphthalene thus get condensed Then number 5, the recovery of benzene. The gases are then passed through another tower where cresol oil, the mixture of phenol derivative is spread and the benzene and its homologue are recovered. The most important is the poisonous gases recovery of H2S and HCN. H2S and HCN and other sulfur compounds are removed from the gaseous mixture when the gas is passed through a chamber packed with moist Fe2O3. So how this Fe2O3 will react with H2S, and so here you can see in this the reaction. This is the moist Fe2O3. When H2S gas come in contact with this catalysis, make Fe2S3 as a solid product and 3H2. This Fe2O3, Fe2S3 we will take out from the chamber and oxidize by using strong oxidizing agent. Then it will give Fe2O3 plus oxides of sulfur. This after some time, when all the Fe2O3 is converted into Fe2S3, Fe2S3 is exposed to atmosphere or on oxidation, regenerate the Fe2O3. So this is the Fe2S3 plus 4O2, Fe2O3 and oxides of sulfur. This is essential to remove sulfur compound from the coal gas, because sulfur along with its oxide like sulfur dioxide or trioxide can promote corrosion. Recovery of gasoline. Gasoline can be recovered by passing the gas into a fractional distillation chamber at different temperature. Different products are recovered like hydrocarbon, carbon संख्या 1 to 4, then petrol, carbon संख्या 5 to 8, then diesel 8 to 11, and then kerosene, and later on heavy oil as the end product. So hoping that all of you would understand about the recovery of byproducts using Otto Hoffmann methods. Thank you.